Hello, bonjour, it's Laura here. In this video, I'm going to show you how to put some of the skills that you have already learned together to solve an even bigger problem. In this question, we're going to figure out the grams that is produced using moles of a different substance. Okay, so here's our question. Nitrogen gas reacts with hydrogen gas to produce ammonia by the following equation. And here's our equation written in green. So nitrogen gas plus 1 nitrogen gas plus 3 moles of the hydrogen gas produces 2 moles of the ammonia gas. So the question is, if you have 1.8 moles of the hydrogen gas, how many grams of the ammonia could be produced? Okay, so what we need to do is write our given and our needed here. So we have 1.8 moles of the hydrogen gas. So that's what we're given. 1.8 moles of the H2. And then what we need is actually grams of NH3. So you can see, looking at our given and our needed, we're starting with moles, we're going to grams. So we're not just going moles to moles, we're going moles to grams. And we're looking at different substances here. We're changing from hydrogen gas to ammonia. Okay, so in your PowerPoints or in your module lessons, you've seen a couple of different plans. So you can refer to the plans. The plans show the given and the needed, and then which plan you should use for each combination of given and needed. So what our plan is going to be is we're going to go from moles of the H2 to moles of the NH3. And to do that, we're going to use our mole-to-mole ratio from the balanced equation. Then, once we know the moles of the ammonia, we can figure out how many grams of ammonia we've got. We can't go straight from moles of the hydrogen gas over to grams of the ammonia. There's no information that could connect those two. We always have to use this mole-to-mole ratio first. Some people even call it the molar bridge. It's what bridges these two substances together, and it's the ratio that we take from that balanced equation that lets us do that. All right, so when we get to this, that's the first step here. When we get to the second step, that's where we're going to use our molar mass. Okay, and I've calculated the molar mass of ammonia already, so it's down here, so we don't have to do that work right now. So you can see we're combining two skills. Like previously, you have looked at balanced equations and done a mole-to-mole ratio, converting from one substance to another. And previously, we've also done videos where we're converting from moles to grams or grams to moles using the conversion factor or the triangle. Now we're putting those two skills together to solve a bigger problem. All right, so I'm going to scroll down and then we can start going through our steps. So the first step is doing our mole-to-mole. So we are given 1.8 moles of the hydrogen gas. We're going to multiply that by a conversion factor, and then what we should be left with is moles of the ammonia gas. That means let's figure out our units here in my conversion factor. I need to have the moles of the hydrogen gas on the bottom so that they will cancel out. And then on the top, I need to have moles of the NH3. That's what I'll be left with. So then, what numbers do I put here? Remember, you take those from your balanced equation. So let's just scroll up a little bit so we can see that. So for my balanced equation, I should write 3 in front of my moles of H2. See that? And then in front of the moles of the NH3, I'll write 2. Okay, and then I'll do that multiplication. So that's going to be 1.8 times 2 divided by 3. So I get 1.2. So now I know I've got 1.2 moles of NH3. That's how many moles of NH3 would be produced if 1.8 moles of the H2 reacted. Okay, so now what we need to do is the second step of our plan. We need to convert between the moles to the grams of the ammonia. So step 2 here. We're done this. Now we want to take this 1.2, that's our given now, moles. Oh wait, we're gonna use the conversion factor method. So moles of NH3, I'm going to multiply that by a conversion factor, and then I'll be left with grams of NH3. Now what conversion factor could I use here? Well, we need to use the molar mass. That's what connects moles to grams. So I need to have moles on the bottom, and I need grams on the top. So it's always going to be 1 in front of the moles of whatever substance you're using when you're doing a molar mass. 1 mole weighs 17.03 grams. So 17.03 grams right here, that's what goes with my grams. Okay, so then I can do that multiplication. My moles of the NH3 cancel out. I'm left with grams of NH4, and that should be 20.4 grams. All right, so we've solved that problem. That means when we have 1.8 moles of the hydrogen gas, that will produce 20.4 grams of ammonia. Very good. Well done, Miigwech.